Welcome everybody to tonight's webinar. We're going to be continuing working with 123D circuit, specifically working to build our PCB that we will eventually be working on in our next lab. So, very brief overview on what we did last class. We introduced the non-breadboard side of 123D circuit, and we started working with, alright, where is it? I think I went a little bit ahead of myself here. Yeah, I totally did. We started working with the PCB design option within the 123D circuit. If you haven't already, go ahead and open up 123D circuit and open up the circuit that we were working on last class, which hopefully should look like this. How do you open up 123D circuit? It's going to be a URL on your computer. If you log in, it should bring you to a home page that will show you your recent designs. And if I'm not mistaken, after you go to your recent designs, it's going to be I believe it's going to be the one that is green here. And I ought to probably change the name of it from unnamed circuit. But all you gotta do is click, and it should show you a preview of the schematic that we worked with. Oops, I did the wrong one. Okay, it's not the green one. Figured I had a 50-50 chance there. It's gonna be the blue one. You weren't here last week. Your sys had to download stuff and your computer was reset. Let's think what I can do here. Does everybody else have this ready to go? I am going to do a quick rebuild on what we did here. Or what I could probably do instead. Alright, Josiah, do you have you have an account on 123D circuits, do you? You need help too? Okay, so yours can't be processed. Okay, so everybody here is having issues right now. Okay. So, don't worry, y'all are not alone. Let me think. Let me see the questions I've got, and let's see which one I can answer first. So, Owen, if you want to go ahead and tell me what you're having a problem with, go ahead. And Tyler, yours cannot be processed at the time for logon. Alright, Tyler, I want you to attempt to log in one more time. I logged in successfully, so I don't think it's an issue with with their login or anything. Alright, so Josiah, this is the link that I'm sending you right now for 123D circuit. If you remember your Tinkercad login, you should be able to just let me log out and start over from scratch again real quick. Hang on. Unless you won't want to do that for me. Please move cat. Yeah, and I sent you the link right there, and I'll send it again in the chat for 123D circuits. So, at that link, you're going to click on sign in, and you'll use your Tinkercad ID and password. And by ID, I mean your email. Do you remember that one? You don't have a Tinkercad account. Whew, okay. Let me see what I can... Did you initially have a Tinkercad account? Did you ever make one? you don't know if you made a Tinkercad account. And so Tyler, you got on by clicking the link. So if you don't remember what Tinkercad is, does any of this look familiar? Not this, but... Oh, you don't remember what your account name and password were. Do you have access to the email that you used? Or do you remember your email? Because the account name's literally going to be your email. You don't know what your email was. So none of this looks familiar at all to you. Alright, so we're going to start from the very, very beginning then. So, let me see what I can do to get you an account here. So alright, Josiah, are you on the 123D Circuits page right here? Do you see anything that looks like this? You should be on just the home page of 123D Circuits. And to those of you watching the YouTube video, I am going to pause for now since this should be a review for most of you. So with much ado, we finally got to the point where I can proceed. You should have a schematic that looks like this on your screen. If you are working on the other thing, go ahead and go back into the circuit that we built last class, which is just the LEDs, the potentiometer, and the screw block. Right. Please raise your hand once you are on this specific screen. Alright. What we're going to do in the upper right hand side of your screen, to the right of this blue box here, there's going to be another option, another icon that when you hover over it says PCB View. And before I go any further, actually, does anybody have any questions on this circuit here? I didn't do a review of it quite yet. I guess I'll go ahead and just real quickly go over it. We started with a voltage source, which is going to be this up arrow right here. That's just indicating that that's where voltage will be occurring. Yeah, how does it work? I'm going over it, basically what this is just a modified LED circuit. So if you remember, we need a voltage source, a resistor, an LED, and a ground for one LED circuit. What we did here is we made two LED circuits and we connected them via this guy right here, which is called a potentiometer. Potentiometers are basically just resistors, but they have a knob on it so that you can turn the knob and change the resistance coming on either side. These items have 3 pins, so you can connect to you can connect to 3 different things. So this right here is a potentiometer. It's connected to one half of the LED circuit, as well as another half of the LED circuit, as well as the ground. So basically what's going to happen if you were to work this design, if your potentiometer just started off neutral, not turned at all, your LEDs will be equally bright. If you turned it in one direction, it will make one of the LEDs brighter and one of the LEDs less bright. If you turn it all the way in the other direction, that will switch. So it's going to determine which LEDs are brighter or not. Question is, can you turn it on and off? Yes, but not in this simulation here, I don't believe. If you wanted to do a simulation of this circuit, you'd have to build it on a breadboard in the other option, the breadboard view. As long as there's a voltage applied, as well as a ground, this circuit will be running. So what we did here by adding this screw block, the screw block lets you plug in external power sources. So we connected one side to ground and one side to voltage, and we made sure that the voltage source is equal on both. And when I say equal, I mean if we click it, oops, hang on, just wanted to build a, if you click on it, you'll notice that a box will pop up that says VCC, name 1. Click on the other one, it should have the same name. We're just making sure that these two things are connected. So that's a crash course in what this circuit does. I'm sorry it wasn't more thorough. I went over it a lot more last class. So what we're all going to do now, we are going to click on the icon next to the blue box here that says PCB View. And it's going to greet us with this lovely little screen here that is kind of stressful to look at. Everybody see that? Anybody having problems with it? And let me actually find where we are in the presentation. I do see a question. You can see it. All right, wonderful. I'm glad that that's not greeting. What do you mean? It's not a good thing to see. Is that what you mean? Oh, the colors? Oh, definitely not. They look awful. But this is, I guess it's just so, I actually don't know. I feel like these are really awful colors for somebody that's colorblind. Is anybody here colorblind right now? Can everybody see this just fine? Okay. This is something I'm going to complain to them about, because colorblind people see reds and greens as brown, which is the background color, so this would be very awful for them to look at. I digress. Let me find where we are in the presentation. Gone a little bit up. Yeah, the brown is not a very pleasant color at all. Alright, a little bit too far there. So, when we're going to be giving a visual representation of our board, 123D Circuit just sort of guesses as to what the components physically in real life would look like. And that includes like the size of the components. What we see right here, we're actually going to need to change. Even though it has all the components on here, it has your resistors, your LEDs, your switch, or your, not your switch. Anyways, it's going to take a wild guess. But in real life, what if our resistors were not that small? Which, hint, hint, they're not. We're going to have to change them. 123D Circuit's cool in that it has this thing, what is it called again? Called a footprint. So let's click on one of our resistors here. If you have something that looks like this, it's going to be called R1 or R2. So we're going to click on it, and in the upper right hand corner, we're going to have one of those screens that'll pop up. Yeah, to change tones. Okay. Did you miss anything? Are you still here? But all I've done is clicked on R1. Alright. Okay, good. In the flesh. Alright. The resistor icon that'll pop, or the resistor box that'll pop up, we're going to want to click on Change Footprint. And so if you remember from last class, um, when you click on Components View, all the components will pop up on the bottom. This is something very similar to that. Um, it looks a little bit different, but it is the same thing. So Josiah, you missed that, so don't worry about what I'm saying. Just note that when you click on Change Footprint, a box will pop up on the bottom. When we built our schematic last class, when we were adding components, it would do the same thing. It would pop up on the bottom. We're going to click on the second option here. And notice that the footprint, or the shape of the resistor, has dramatically changed. It's gotten a lot bigger, especially if you compare it to R2 here. So again, what I did is I clicked on, you don't see the footprint thing? Alright, I'll do it one more time for the second resistor, but you'll be doing the same thing with the first resistor. I want you to click on your resistor so that a box will appear in the upper right hand corner. If you click on it, a box that says resistor should pop up. Y'all see that? A box right here. If you click on Change Footprint, a new screen will pop up on the bottom. And you're going to choose the second option. Yours does not look like that. Alright, you're on this this brown screen, right? The brown and black. Your resistor is backwards. I think you... Is it like upside down? Your resistor? Because it should be okay if your resistor is backwards. It shouldn't really matter right now. The yellow spot is wrong. Don't worry about the yellow spot. I'll go over that in a minute. Overall, though, it should look something like this. It should just look like a big old resistor or a big old box with R1 and R2 inside of it. And you might see a yellow spot. That's fine if you do. If you don't, that's fine too. Everyone at this point? Where your two resistors are all big like this? Your circle went off the screen. Josiah, hit Control Z, and it should come back to its original position. If you're on a PC, Control Z. If you're on a Mac, Command Z. Z is in zombie. So I talked about the menu. What was the second option? You mean this right here? Oops. The one that looks like a skinny line, skinny white line in a black box. The second option, Control Z, is Command Z. It'll be CMD. And that's only for a Mac, Command Z. You can also hit the undo button, which is right here, if you move something that you don't want to move. You get your circle back in place here. Did you get it worked out? You got it? Alright. So notice how much bigger the resistor much bigger that we made the resistors. That's literally what the resistor size would be in relation to the board when we're soldering. So if we have the wrong size, it's going to be difficult to solder and we're going to have a bad time. So that's why we're making the resistors bigger. So make sure that you've made both of them this new kind of resistor. So we're going to do the same thing with the LEDs, but the LEDs are a little bit different because there are all sorts of sizing options. But luckily it's not too crazy difficult to fix it. We're looking for, before I do that, we're going to click on the LED, which is going to be, it's not the potentiometer. Where's my LED? Where are my LEDs? Oh, there we go, the diodes. So we're going to click on our first diode and do the same thing, where we change our footprint. And we're looking for LED 5mm. Anybody want to take a wild guess at what LED 5mm stands for? Any wild guesses? Yeah, exactly. 5mm, 5mm LED. Perfect. We're going to change those LEDs to be our 5mm LEDs. So similarly, there's a 10mm. There's another 10mm with a different sort of function here. 5mm is all we're going to be looking for here. You can also search for it if you prefer. It looks like mine's going to be on the very bottom, of course. Yeah, we're going to type in our search box LED, 5mm. We're going to change our diodes, which was D1 and D2, to be LED 5mm. The one with the really thick eyeballs. It looks like there's two of them. Not eyeballs, but pins. They just look like eyeballs. The thick circular pins. Not the thin octagon or hexagon. I don't know which. Hexagon. Alright, and I might have done that wrong too, actually. And I did do it wrong. Which is why it's important that you are on point here. because clearly I'm not right now. There we go. Same thing for D2. Did I do that wrong? I did do that wrong. I'd like you to raise your hand once you've changed both of your LEDs to the appropriate footprint. Alright, so if you haven't gotten this yet, please let me know. Else I'm going to proceed to our next step here. We've changed both of our LEDs to be the correct size. And at this point, we are going to address what some of you may see on your screen, these yellow dots. So you can see 2 on my screen have yellow dots. And that's not a good thing. It's easily fixed, so don't stress about it or anything, not at all. Basically, these yellow dots, they mean that there's something wrong with the design. Specifically, it happens when something is overlapping or when something is going over the edge of the board. It's kind of hard to solder something that isn't even on the board, right? So if you see that, all you have to do is move your object so that both of the pins are on the board. So apparently it takes some finesse. And that'll clear up your yellow dot situation. So go ahead and clear up those dots if you have any. Because here's the part that I've been looking forward to doing all class. We're going to be arranging our components and then connect them all together, which sounds real boring, but wait, it's actually pretty cool. So let's see here. You have a challenge to get all of your components put together so that they take up as little space as possible. So what I mean by that is what I have on my screen. Oops, I see a question before I go on. It must be very fun. I think it's pretty fun. So what you see on my screen here, the brown is currently the boundaries of our PCB board. Right now I have a whole hodgepodge of stuff on it, right? I have a diode over here, and then one hanging out over here, and then there's a switch, and then there's a potentiometer. It's pretty wild. What we're going to do is try to squeeze our components as close as we can together. Whoops, I did that wrong. I'm not very good at this, at moving stuff either. We're going to move our components as close as we can together, but we would like to, let's see, we would like to minimize the amount of green that is flying around. So all these green lines, I'll tell you what those are either later today or next class. We want as little overlap as we can possibly get. Alright, so pretend I'm not talking about the green lines, but for example, this might be a decent way to look at it. I'm actually going to make this kind of a challenge for us to see how cheap we can make these boards. But our thought puzzle is to put all these pieces as close together as possible and minimize the amount of overlapping on the greens. So as a note, you are able to rotate components by having it selected, and I think you can hit R, or you can click on this in the upper left hand corner. It looks like two triangles being rotated. So rotating components may very well help you in this. There's a reason we're doing this. If you do need to go, you can go. Just remember the challenge you're going to be doing. Yeah, take care, Samuel. So let's see if I can make this even smaller. It's not the end of the world if you do have these green lines crossing over each other, because I'll tell you next class probably how we can get around that. But minimizing it to start with will help you when you start wiring this. If you think you found a good configuration, what you can do, if you click on one of the corners of your PCB board, whoops, not like that. What did I do wrong here? Well, that's not what I expected. Give me 1 second, folks, sorry. We're going to resize the circuit board itself, and I don't know why I'm not having any luck doing that. Let's see. But what we're going to try to do... Oh, here we go, that's why. What did I just do here? Why on earth did it do that? I don't want the grid to be on front. Well, now I can't even choose the circuit board. That's being annoying. Alright. Ultimately, our goal is going to try to make it as cheap as possible. The cheapest price for 3 boards I've seen is $15.28. If you can get it smaller than $15.28, we will talk about, or we won't really talk about it next class, but I'll be impressed. So that being said, it is almost 7 p.m. Oops. So if you have any last minute questions before we head out for the night, go ahead and ask them now. Otherwise, you are free to go. I appreciate you coming out today. I'll upload the video in just a moment. And it was great